Hey, and welcome to hour 5 of the Tournament Logic 24-hour charity for Engineers Without Borders. And in this hour, we have a kind of an Irish science special. We have from 60 Symbols, Professor Philip Moriarty.
Hello.
And well-known vlogger and blogger, Science of Sarcasm.
Hey.
And Tournament Logic's very own talented blogger, Severme.
Hello.
And this hour, since we are all at different levels of our scientific careers, we're going to be talking about the Irish science education system. So I think a better place to start would maybe be the Leaving Cert, science education in the Leaving Cert. So maybe I think, Sarah, you could start us off on that, maybe discuss.
I think there's a necessity to do so many subjects, and with languages being compulsory and English being a compulsory subject, that it makes it hard to specialise in science at Leaving Cert level. I've been incredibly lucky that I get to do all science subjects offered at the Leaving Cert in my school, but I think for most people it's quite difficult to just do science.
I must admit, so I've been in the UK system for quite some time. I did my Leaving Cert a long time ago, back in 1985. But I've recently, this discussion is really interesting for me because I've recently taken over as admissions tutor here at Nottingham. So I get to look at applications from A-level students. And I honestly think the Leaving Certificate, because it's so much broader than the A-levels, is a much better system. I think actually having people doing English right to the final year of school is a very good thing indeed, because if you have that specialism too early, I'd love to say that I spend, the vast majority of my time working with numbers, doing experiments, etc. But a very large fraction of my time is spent writing. And some of the undergraduate reports I have to mark, if there were a few extra years of English in the A-level system for everybody, I think that could only be a good thing.
But it's a lot of English criticism and literary criticism at Leaving Cert, and a lot of learning off quotes and poetry. Maybe if they had a kind of foundation level English, which was compulsory, but you still got fair enough marks for it, because a lot of people do higher level English for the poems. It just makes it difficult when you're doing like learning off loads of quotes and stuff, and I don't really see how that increases your ability to write reports and stuff.
But I'd hope
just my personal.
Yeah, no, but I'd hope it's more than just learning off quotes. I would hope that they're trying to get you to, critically analyze this stuff and to think about, the various different interpretations you can place on the text. Certainly when I did leave certain English, and that was a long time ago, yes, you were expected to learn off large chunks of, Shakespeare, etc. Whether that's the best thing, I don't know, but certainly having some exposure to Shakespeare, discussing that, getting a handle on what he was trying to get across, and sort of how that connects with so many broader themes in life. I think that's a pretty good thing to be doing. Let me just open up my comment window here. Okay. Yeah. Okay.
Yeah. I'm studying history as well, and I feel the abilities.
You're breaking up, Sarah. I can't really. Yeah.
Yes, Sarah's gone, or is she?
I don't know. I don't hear her. Shane.
I'm having internet troubles, I think.
Breaking up. Shane's audio stream seems to also be breaking up a little bit.
Forgot.
So
Shane,
can you hear me any better now?
Yeah, we can hear you now, Sue.
That's better. So
Yeah.
The curse of the live stream has hit us very early in the hour.
Well, maybe we'll just get it out of the way early on. And
Yeah. It could have
Hopefully
been
the
worse.
Wi-Fi will keep.
so, where are you, Shane? Where are you an undergraduate at the moment?
Uh,
It's breaking up. Can everybody else hear
Yeah,
Shane? Because I can.
No, I can't hear.
I was
no.
going to say, Shane, could you try turning off your webcam to see that might help it?
okay.
And we'll see if that can improve. Let's see if that works.
Can you hear me now?
Perfect.
Yes, that's good.
Well, I'm currently, because I tend to annoy a lot of people on the internet, I prefer to remain somewhat pseudo-anonymous.
Okay.
And not to give out personal details, but I'm currently studying it's in the biochemistry field.
Okay.
And at the moment, one of the main things I see with the undergrad level in science in Ireland is the amount of specialization that can be required of people straight off the bat who are just coming from a very basic level of knowledge given by the Leaving Cert, and they have to make really specific decisions about where they want to go. For instance, you can come out of doing your basic high school level biology and chemistry and then decide there and then to dedicate 4 years of your life to becoming a human geneticist or a toxicologist. And it's very... Considering how much there is to learn in those fields and the fact that the students themselves don't know what it entails beforehand, I think it's a really big ask to get people to make that kind of dedicated decision straight off the bat.
Yeah.
So I've heard that the new system, which they're going to be trying to work in over the next few years, is it'll be more like almost the American credit system, where you build up the basic level. Like you'll do the introductions to molecular biology, the introduction to cellular biology, to physiology, and you can just build it up piece by piece.
Yeah,
That's where you specialize as you proceed. Once you become more and more familiar with the material you're going over, you can make decisions based on what your aptitudes are. And also give us money. I'm just being told that I'm supposed to be asking for donations.
give us your money. Let's do a geld off. Yes. No, it's interesting. The specialism side, I guess the way that feeds into the degrees here is in terms of modularization, and pretty well all UK degrees in physics anywhere, or never mind pretty well, I'd say all UK physics degrees are modularized now. But in some ways, the modularization sort of makes you, on a module basis, really focus down into specifics of that module, and sometimes it's very difficult to see the broader picture. But the other benefit of it as well is that you are allowed in many cases to take modules even outside of physics. So, I've had tutees who've done, not just computer programming and things like that, but something in classics, or something in philosophy, or something in psychology. So there is that possibility to broaden out a little bit, which I guess is one of the few advantages of a modular system. How did this level of specialization or specialism sort of, how did that get integrated into the system? Has this been it's been there from the start, do you think, or has it been something that's developed over the years?
I think it has mostly been there from the start, and people at the Leaving Cert level, rather than, say, going from the Leaving Cert to the higher certificate, which would be the 2-year equivalent of an American associate's degree, rather than going to that and then branching off, people are actively encouraged to go for the higher points courses, such as the degrees in genetics, the degrees in biochemistry. I think people feel, well, I'm looking at this higher cert, it's only perhaps 275 points out of a possible 600.
You're breaking up again. It's a shame, because what you're saying is very interesting. I wish I could hear it all.
But actually,
can you hear me now?
Yeah, that's good. It's just it broke up a little bit there.
I was just thinking, people, they see the point system, it kind of creates, whereas For people outside of Ireland, the Leaving Cert is scored on a point system of 600 points, with 100 points coming from 6 possible subjects which you can choose to do for your Leaving Certificate. And each grade, such as an A1 or an A2, a B1, and so on, gets a set number of points, and then you get into each course dependent on whether or not you have enough points to meet the requirements, and the requirements are based on how many people are applying and what number of points they got. So it's more of... Sorry, go on.
So the very interesting thing is because time and time again in the UK they've tried to introduce a market in higher education, which fails time and time again, because the thing that drives student choice is really the sort of prestige of the university, rather than, exactly what you've expressed in terms of demand and in terms of what the general perception of a course is. It seems that the Irish system to me is a hell of a lot closer to a market system, and that you've got points, and those point levels are, as you say, dependent on the demand for the course. Is that fair to say?
Yes, and it can create the false impression that decent courses, like if you wanted to get a basis in biochemistry before specializing, it can make you feel as if those introductory courses, the 2-year courses, are somehow less worthwhile because less people are applying for them, which means that the points are lower, which means that they look less valuable to people who are considering them.
It's really, the parallels here are very, very interesting, because we don't have points in the UK. We have this very strange system where you have predicted grades, and offers are made on the basis of those predicted grades, and often those predicted grades are pretty well spot on, interestingly. But so what you end up with is, instead of the points, the offer is driven upwards. So you've got this again. If we're a physics department and we offer BBB, and another physics department offers A star AA, then the very interesting thing is that often the department with the higher offer ends up getting more applicants, because it's seen to be, as for exactly the same reasons you've just outlined, seen to be a better course, whether it is or not.
And the point system actually has its own set of negative flaws. It has its own set of flaws. For example, courses like medicine are extremely competitive, and you need to score almost perfect in order to guarantee a place in a medicine course in Trinity or UCD. The downside of this is that although you're getting people who are very academically gifted, you may be pushing out people who are qualified to be doctors, who are more suited to be doctors than the ones that are just very hard studiers. People who may not be suited for medicine. And I think that's why they're going to bring in
the point system.
A second requirement, such as an interview. I know they've been talking about bringing that in. I'm not sure if that's the problem. I'm not sure if it's in yet, or in the course of being implemented.
That's certainly something we have in the UK system, and those interviews tend to be very, very eye-opening. And there's also something called a personal statement, which every candidate has to complete. And those personal statements are also quite interesting. You tend to see the same, how can I put it, books being read time and time again, and there's a clear, how can I put it, training in terms of how to write personal statements, which when you couple a personal statement together, or consider the personal statement along with the interview, that is actually a pretty good way of distinguishing between candidates, I think. But it's an exceptionally time-consuming process.
Well, if Sarah's audio is working, I mean, she's going through it at the moment, so exactly. What's her feelings about it?
I think it puts a lot of stress onto... Yeah, it puts a lot of stress onto 3 hours of just an exam. You can put all the work in for 2 years and then just not feel well on the day of the exam, and then it just feels like it goes all everywhere. Maybe a bit more continual assessment or something. Just there needs to be some change in it, in my opinion.
Yeah. So at the moment, is the coursework continuous assessment for many of the Leaving Cert courses?
Well, Ag Science is the closest. You have to do a project.
Okay.
But the project takes hours to do and is only worth 30% of the final grade.
30.
And that's with 30%, and that takes, like, I've started mine already, and mine's not due till like April.
Is that agricultural science, or which science is that?
Yeah.
Okay.
That would be agricultural science. And there's also plant identification and stuff in that constitutes some of the mark, but it's not really enough of it, because it's still weighed down on the 3-hour exam, which...
I remember when I was doing biology at higher level in the Leaving Cert, and one of the... I'm not too sure if you could tell me that there was a mandatory fieldwork project, which was odd because it's mandatory. You have to do this. And when they send in inspectors to the school, they'll be asking to see these projects, and they're not marked. They weren't marked. They didn't go towards our final exam. It was just an exercise. It was just. Is that still going on?
I don't know if it's the exact same, but we have to have an experiment copy with I think it's 24 experiments in that have to be done, and they don't go towards their final mark. The same as in physics and chemistry.
But it's like a threshold. It's like you have to pass them basically, and that's it. But it's like, but you don't get any marks. It's bizarre.
I don't know if you even have to pass them. I just think they have to be done, because I don't think teachers have corrected mine to see if I know what's happening fast, but like there's no kind of, if you get it wrong, it's just improve it for the next time. It's not go back and fix it. So why? I don't know if you even have to.
And this is a really good opportunity to really teach how to go about science, how to not only just learn the theory, but actually getting hands-on. How would you go about this problem, setting out your experiment and then analysing the results? That's a huge part of science, and that's left out arguably until the last year of your undergraduate. If you go on to go that far in science.
But you do lab work throughout before you get to. You mean the lab work is too prescriptive, and it's really only until you get to the undergraduate project that sort of true science is done. Yeah, I think there's a lot to be said for that. The idea that the problem is that with undergraduate labs, what you end up doing is obviously, for a variety of reasons, experiments that have obviously been done before, and you get into the mindset of, well, what I'm trying to do here is reproduce something that might have been done 150 years ago and get the same value, which of course is not quite how we always do science.
Yes, and actually there was although I remember in my first year in DCU, in the chemistry lab, one of the projects was actually, you have a sample from a river, you're given a scenario, and you're asked to test, what would you test? You're asked to test the water, and what tests would you do? You're asked, this is what you want to find out. What tests would you do to find out this information? And then we went about in our group, and we just, it was all based on previous experiments, but you had to figure out what experiments would you do. And I thought that was immensely helpful.
So one of my first my first job really as a lecturer was to revamp the second year undergraduate lab in Nottingham to introduce an interfacing element using something called LabVIEW, which is an interfacing program. And what I tried to do, like people before me and people after me, was to try to not make it prescriptive, to try and make it as open-ended as possible. But the problem then is that given the constraints on students' time, given the fact that they have to get marks, the difficulty is that although you try to make it open-ended, what generally happens is that in the lab, the students get so far, they get stuck and they say, well, what do I do here? What do I do here? What do I do? And you get a series of questions asked of the demonstrators. And the problem is the demonstrators sort of drip feed the students towards a solution. And it's really difficult because just due to the constraints of the timetable and the sort of logistics of the setup, and the fact that, in our second year now, we have 180, 200 students, just getting them the sheer demands of getting them through the system means that what might be the best educational approach is sometimes deeply frustratingly very difficult to put in practice. And I think that's one of the irritations of teaching in a university sometimes, is that you might well want to try and do the best sort of things for the students educationally, but you're stymied by, you know, all the other constraints about how do we fit this into the timetable. Maybe, yeah.
So I just go into my topics.
I think a lot of it as well with the Leaving Cert, the complete lack of practicality makes it very hard for people to choose which discipline they might go into. I know, personally, I actually completed Leaving Certificate Biology without having ever dissected anything, even so much as a worm. Now, I'm not like really disappointed that I didn't get to cut up any animals. Like, I'm not a Dexter character, but at the same time, I got through that course and got a decent mark without having done any practical on physiology whatsoever.
Yeah,
I think the lack of practical work going to being included in the points at the end of the year kind of gives schools the opportunity not to go into it as much as they should in order to prepare their students.
Yeah, there's been huge debate in the UK. Very interesting you should say that about the A-level physics and the extent of practical work and that. But again, the problem is, in many cases, is what Michael was saying earlier, that what was being taught was sort of, again, very prescriptive. Students were directed, led by the nose to a particular solution. Examiners were sort of almost looking for keywords rather than really checking the scientific method. But I absolutely agree, to do a science subject without having any type of practical element of that is not a very, very good way to, you know, to get good practice.
Yeah. And when it's advertised at fourth year, and when you're doing the open days for secondary schools, they almost advertise these science subjects as, this is what you'll be doing every day. You'll be coming in, you'll get a little bit of theory, then we'll be doing the experiments. That was that was my experience going out to all the open days when I was 11, 12, going to pick my secondary school. And then when you get into this, it was almost pretty much experiments were a rarity. So that was almost very disappointing and a bit disheartening. And also,
but even even sort of in terms of demonstrations in the class, even if the students weren't actually doing the experiment themselves, were the teachers using many demonstrations, sort of real world demonstrations? And
it was very rare.
Wow.
But they were doing.
Sarah's breaking up again.
I think I might be getting a little bit better in terms of experimental. It's probably not really, but we've done, in chemistry, we've done a lot of titrations in particular. I think we've done about 12 of them this year. And most double classes in the sciences, we would be doing an experiment.
Oh, that's good. Okay, that's good.
Because the experiments is getting just a little bit of lab practice, just knowing how to handle the chemicals or the glassware. It's going to be very beneficial when you go on into first year chemistry or first year biology. It also saves the demonstrators a hell of a lot of headaches. As a demonstrator myself.
In chemistry especially, it's very easy to get things wrong. I remember in my secondary school, the chemistry lab I had for Leaving Cert Chemistry had a scorch mark on the ceiling, which was left as a warning to future students, because the titration had gone wrong when someone forgot to remove the heat and then dropped all their alkaline at once.
Lovely.
Wow. Those
Sarah, I'm really interested. You said you're doing 4 science subjects, so one of them is obviously physics. Do you get taught about experimental uncertainties, error bars, normal distributions, Gaussian distributions, how to treat your data statistically?
Not particularly, no.
Okay. So there's
we have to, if it's anywhere relevant, we have to, at the end, if an experiment goes like completely wrong, we have to do a section in our lab copy about sources of error.
So there's going wrong and there's actually going right and having experimental uncertainties. So quoting I don't know, say you're doing something to measure the value of g, small g, acceleration due to gravity. I hope what's built in is quoting that as 9.7 plus or minus 0.5 or whatever meters per second squared. Do you see what I mean in terms of experimental uncertainties?
Yeah.
Okay,
yeah,
so
we
that.
Yeah.
Okay.
We haven't done much of that. We either haven't done it or I haven't been paying attention when it was done.
Okay, that's interesting because there's a quote from I'm quoting him slightly out of context, but Pauli was very, how can I put it, scathing sometimes, and he described some colleagues' work as not even wrong if he didn't like it. I think there's a fair argument to be made that if you quote a value, experimental value, without quoting the experimental uncertainty, without quoting the error bar, what you've done is not even wrong, because you can't compare it against anything. Because if it's a 5% error bar or a 100% error bar, that makes all the difference to comparing it either to theory or to other experiments. And that's one of the things, and certainly I remember uncertainties when I got to undergraduate level and going, oh, this is just so tedious. But the problem is like Ben Goldacre says, so many important things in life are sort of hidden behind or buried behind a force field of tedium. You just have to, you have to have this stuff there. And embedding that as early on, we get the idea across that, you've got to take account of the experimental uncertainties is very important. And it's certainly, I think it's something that's lacking at A level. And from what you're saying, it sounds like it might be lacking to a certain extent at the even cert as well.
Yeah, it's also very easy to hide bad science behind a fog of annoying math. I saw when it was Ben Goldacre again, he had published on his blog a thing that showed that when people were dealing with their p-values in the drugs trials and that, they got twice as many just above the threshold as they expected and half as many beneath the threshold, which was showing that people were probably starting to fudge their data and try to interpret it in a way that they really shouldn't have been in order to get it over that probability threshold.
Absolutely. There's a very famous paper. It's a guy called David Colquhoun. I don't know if you're familiar with his blog. Ben Goldacre refers to him quite a bit. So he's a pharmacologist at UCL. He's emeritus now. He's retired. But his blog, which is called DCs for David Colquhoun, Improbable Science, is if you're into Goldacre, you'll really like his blog. Now via his blog I came across a paper which was called, it's published some time ago, 2005 I think, Why Most Research is Wrong, and it's exactly as you suggest in terms of the abuse of p-values. It's interesting, physicists, certainly in my area in terms of condensed matter physics and nanoscience, p-values are not something that we really use that much. Indeed, the idea of an hypothesis and then checking that hypothesis, which you might expect to be the very bedrock of science, certainly there's not a huge amount of science I've done over the years where I could say, right, here's an hypothesis and what I've done is check against that hypothesis. A lot of what happens in nanoscience, at least I would argue, is exploratory. It's not driven very much by here's the theory and we're going to do an experiment to check against the theory. It's what happens if we do this, and oh wow. And generally what's happening is almost that the theory is lagging behind the experiment rather than vice versa. So it's interesting the very strong differences you can have in methodology and culture from discipline to discipline, and even from sub-discipline to sub-discipline.
I think it's time to remind people that we're not just here to bore them with science talk, and that we're actually raising money for Engineers Without Borders.
Yes, indeed. So please contribute.
Actually, just on the transition from Leaving Cert to university, in Leaving Cert, it's a very holding your hand type of system. You know, no child left behind. That it's very a nurturing environment. That you're pretty much, you know, spoon fed. Well, not spoon fed, but you're kind of helped along. Then it goes into university, where it's kind of a bit of an awkward transition to that environment, because it's very much self-learning,
sink or swim.
Yeah, sink or swim.
Do you really find that?
No,
both you who've gone
if you're putting in an honest effort, and if you're having difficulty, there are usually tutorials with the lecturers, and there's usually a course coordinator who you can go and speak to. They leave an hour free every week for people to come with any issues, and I have found them always to be quite open, and there's nothing you're having trouble with that someone they haven't taught before hasn't already had trouble with. So just go in, send them an email, make an appointment, and go in and talk to them, and usually they can always find a few minutes to sit you down and get you through it, because even if you happen to be given the worst, most Hitler-esque lecturer in the world, your performance reflects on their performance, so they still want you to do well.
I just mean that's kind of a perception that's out there about university, that it's kind of it is a sink or swim, and that may put people off, but it is at least in first year that you are given a bit of a transition.
Yeah, I think that's just the absence of the Irish mommy there to remind you to do your homework and get up on time.
Indeed. Let's not slag off the Irish mommy, though. So the interesting thing is, we are very, in Nottingham at least, and I think this is true right across the UK, we're very, very much aware of that step from A-level or Leaving Cert to first year. So we've done things like, for example, the physics course at A-level, pretty much all the maths has been stripped out of it. So that, for example, calculus is no longer in the A-level physics syllabus, which, you know, has Newton spinning. I
don't understand how you could do that. But then I only took physics for my first year.
So the argument is that that basically, you're doing physics, you're generally doing maths alongside it, and even further maths. So that's will shunt all the maths that we need into the maths course. That's very dangerous, because it's you know, maths is very much the language of physics, and if you decouple it and, you know, have these separate entities of you do your physics here and you do your maths here, that's just stupid. And so we worked really hard in first year in the university, building up that mathematical background, putting it back into the physics, precisely because we don't want people to sink or swim. We actually do want to get them through. This is sounding like an awful advertisement for Nottingham, but I'm not meaning to do that. But it's interesting. Michael should say that. There may well be that perception. I'd say the reality is, I can't speak for the Irish courses, but certainly the reality in the UK is that we put in a lot of effort on the math side. I would argue, going back to what we were discussing right at the start, we really need to start putting some effort in terms of, you know, English language ability, grammar, punctuation, why it is not appropriate to use 14 semicolons in one sentence, this type of thing.
Yeah, I think that's sorely missing in the university setting, the language of science, the how to communicate, because I know just through my undergrad that our class got several complaints from the lecturers correcting reports that the English was absolutely atrocious. In fact, one of our lecturers, who actually has his own blog, it was actually our third year report was actually a subject of his blog, which we weren't favourably mentioned.
It's interesting. So you've got to be careful, I guess, in terms of talking about. I blog for the Institute of Physics, and one thing that's on one of the blogs I have in mind is something called punctuation is not optional. because it really is. I'm not talking about, the difference between it's with an apostrophe, it is, and, it's in terms of the possessive form of that, or THEIR spells THEY apostrophe RE. I'm talking about sentences that are literally, you cannot understand them. The sentence construction, the punctuation is so bad that you cannot understand what the student is trying to get across. And that's not the majority of cases. I'm not going to overstate this, but it's a sizable minority. And that's at one end of the spectrum. At the other end of the spectrum, you get people who can write quite well, but there is a large fraction of the class that struggles very badly with writing clear, grammatically correct English. And the problem is, the first, when you then go on to get try and get a job, or go on to try and get a PhD position at the end of the degree, the first thing your employer, your prospective employer, or the person who's going to, consider you for a PhD is your cover letter and your CV. And if that's riddled with grammatical errors, you go down the bottom of the pile, because in many cases you're competing with people whose grades are at least as good as yours. So we are looking for anything to sift out those applications. And if your English is sloppy, then you both or all of you've heard this before, but it's increasingly problematic in terms of the overall language skills.
And even just on report writing, I remember maybe this is just for my year, but maybe I also hear from other undergrads that I hear when I demonstrate is that when they're writing reports, they don't say, "Oh, I found out this bit of information," or "I brought up this." Sometimes I do, but they always talk in terms of the amount of pages they've written or the amount of references. I have 30 references. I have 50 references. Yeah. I've written about this much of paper. I've written this much. Of course,
what we do to grade them, of course, is weigh them as they come in, and we go, "That's so many grams or kilos, therefore it'll get paid." Yeah, it's no. The problem is you can say something a hell of a lot better sometimes in 4 pages rather than 20, as you know.
Definitely, and sometimes I even write me reading papers. I was actual published papers. I sometimes feel that they just waffled too much.
Yeah, but the other problem with the papers is the scam that is publishing. The editors of those journals, the typesetters, the proofing, so much crap gets through. And that's just from our group. So it's remarkable. We pay very high subscription fees. We do the refereeing for free. With open access now, you have to pay, in some cases, for example, for Nature Publishing Group journals, you might be paying $3,000 to make your paper open access. You might hope that the proofing and the editing process would be, an integral component of that. But often, so much very poorly written stuff gets through.
I think
could that be down to the fact that their ability to pass exams in science and particularly understand science isn't necessarily connected to the ability to understand English? So you could be very good at designing experiments and everything, but when it comes to writing down, then you're not so good. So,
but the problem is you need both. I agree with you. There's certainly there's an aptitude there in terms of the arts and humanities versus the sciences. But the problem is it's you have to be able to write. It's the argument that I'm just good at designing experiments. I'm good at doing the mathematical analysis. The problem that's an important aspect of it. But without the ability to write and to communicate your work, because that's what science is all about, is disseminating your results, getting them out there. If you can't do that in a clear fashion, we're not looking for Shakespeare. We're definitely not looking for Shakespeare. Just the ability to write clear sentences and understandable sentences. Unfortunately, a lot of people, I guess, might come into science and think, well, that's great. I won't have to write essays. I won't have to really concentrate too much on my language abilities. The problem is that's a misconception. That's a real misconception.
Yep, and actually, I just know, I won't name any names, but I know there are a few research groups that I know that are quite large, is that they can almost focus on certain people to do certain tasks for the group. You'd have one group person who would do the presentations, you have another group person who would concentrate on the writing. And although that may increase the productivity of the group, it's not really good for the people who are in the group itself. It's not good for their education, and it's not good for the future. No. And I'm not too sure if you've come across that as well.
So the easiest thing in the world for me as a principal investigator, the easiest thing for me to do is to get the results from the students or the postdocs who've done the work and then write it up. That's the easiest thing in the world for me to do. But that's not going to help those people write better papers. So what has to happen is that they have to do the first draft. It goes to me, and it's soul crushing. I remember my first one. First draft of your paper, generally you submit it, comes back absolutely dripping with red ink in terms of you change this, move this, you can't say this, you can't do that. But that's an iterative process. And without that, going through that pain, you're never going to be able to write scientific papers. So you're absolutely right. If you want to enhance productivity in the sense of the group churning out papers, then yeah, maybe you can identify the person who writes the best and get them to do the job. But as you say, that's doing a major disservice to all the other students and postdocs in the group, because there's a research element, but there's also a training element. Certainly in the UK, and I'm sure this is true in Ireland as well, a major, in terms of the funding bodies, they don't only see PhD students and postdocs in terms of generating research. They see, them being embedded in a group and being skilled.
Sorry, there's a bit of background noise coming from you.
This one. Sorry?
It sounded like a TARDIS for a second. I'm a huge Doctor Who fan, by the way, so I went with my daughter to, completely off topic, but given that your logo here is a TARDIS and I'm looking at it all the time, I went with my daughter to the 50th anniversary Doctor Who celebrations in the Excel Centre in London last year. She's 8, so she's a huge Doctor Who fan. That was a really, really good day. Really enjoyed it.
But how do you as a physicist deal with the paradoxes?
Sorry?
How do you as a physicist handle all those polar time paradoxes?
Yeah, but it's science fiction. It's all about suspension of disbelief. That's, it's again, sometimes we physicists can be just a little bit too literal, and that's, literal minded. It really doesn't affect me so much. And I enjoy Doctor Who. Let's put it this way. I grew up with Tom Baker, moving into Peter Davison, and then for the next few Doctors, Doctor Who really reached a nadir. It couldn't get much worse than where it was, sort of late 80s. So when it came back with Eccleston, I was massively impressed.
Well, you obviously never watched the American made-for-TV movie version, because it
got
worse.
Was bad with McGann, with Paul McGann.
Yeah, I mean he would have been a brilliant Doctor, but he just did not get the showing he required.
Anything from the UK that America tried to remake, they don't really seem to get it really well.
Something quintessentially
like Red
British,
Dwarf.
like Red Dwarf. Jesus, yeah. So yeah, no, those are quintessentially British. One of my favourites, I don't know if you've heard of it, something called Blake 7. No, nobody's heard of it. Oh dear. So that was a wonderful science fiction series, let down by perhaps it was even worse than the Doctor Who budget. They really were working on a budget of 50p and a ham sandwich, because some of the sets are laughable, but the stories were great. Anyway, we've gone quite a way off education, so.
Just maybe as a transition, we are $70 away from raising 2,000.
What?
Which is our mark, which is where we were hoping to get. So if we can get that by 15 minutes, just the top of the hour, I don't know what kind of incentives we could.
So give us your money or else we'll spend the last 10 minutes talking about p-values.
Yeah, that should do it. That should do it. Ah!
Just, Phil, as someone who's researching in physics, I know in the biological sciences like pharmacology and that, there's a few notoriously bad papers like the Seralini rat study or the recent Australian pig feed study where lobby groups with an agenda to push have really put out some bad science. And I was wondering if there are any physics equivalents of that.
Oh, so we've actually been, it's not really physics, it's more chemistry. In fact, what I do is right at the border of physics and chemistry, so I could call myself either a chemical physicist or a physical chemist. We've been embroiled in a debate for the last, it seems like aeons, but it's actually just the last year, on artifacts in scanning tunneling microscope images regarding nanoparticles. And there have been arguments that if you put two types of ligand on nanoparticles, gold nanoparticles, they phase separate and form stripes, and that those stripes affect, for example, important things like how nanoparticles get into cells, whether they can penetrate cell membranes, etc. Now, it turns out that those images of stripes are an artifact, very bad, very rudimentary artifact. And we recently, basically just on Friday, got the referees' reports back on a paper that we'd written which sort of critiques this, which was a long, hard slog in terms of finding people to referee the paper. And it took the journal in question, PLOS One, 6 months to actually get this to us, get the reports to us. But yeah, so that looks like that's going to go through. It had fairly enthusiastic and supportive reports. But the very interesting thing about that is not so much that there was lobbying or deliberate defrauding or deliberate data manipulation. It was that it was just mistakes. But those mistakes, time and time again, these were published in the top tier of journals: Science, Nature Materials, JACS, Journal of American Chemical Society, which is a fantastic acronym for a journal. Proceedings of the National Academy of Sciences, another wonderful acronym, and the very top tier of journals. And what's very interesting is the sociology of that, where the first paper gets into Nature Materials, then the referees get to based on an artifact. Then the next paper comes along with the same artifact, but what the referees clearly have done is, well, the last one got published in Nature Materials. They obviously know what they're doing, therefore this one must be good. And then it builds and builds and builds. And I used to be a very enthusiastic supporter of peer review, and like democracy is the best we've got, but there are major deficiencies in peer review, and this sort of stripy nanoparticle saga has brought that through to me.
Actually, that also reminds me of the nano chopsticks one, which was delightfully hilarious.
It's interesting. Did a video with Brady Harron for I don't know. It might end up in 60 Cents. It might end up on periodic videos. It depends on where he puts it, if he actually uses it on that very subject, and showing just how awful the peer reviewing process was in that case. That's a really shocking demonstration. For those of you who don't know about the nano chopsticks thing, just if you Google nano chopsticks, you'll probably, the first thing that will come up will be a blog called Chembark, and what that discusses is a paper that was published in Nano Letters, which for many people in nanoscience, we'd consider Nano Letters the next tier down after Science, Nature, etc., PNAS. And basically photoshopped, the worst photoshopping job that you could ever imagine. Just my 10-year-old daughter, actually, when she saw it, she said, "Daddy, why didn't I cut round the things right?" It's just, until you see the image, you won't know what I'm talking about. But if you Google nano chopsticks, you will be absolutely shocked that could get through peer review. And again, it's showing up severe deficiencies in the peer review process. But one of the advantages, one of the, I guess, the encouraging things are there's a real move to using social media, to using Web 2 or whatever you want to call it, post-publication peer review. There's a site called PubPeer where people post comments on papers after they've been published, and that's been exceptionally important.
And actually, just on the probably maybe after peer review, studies can still get taken down. Just a recent example I just want to bring up is the acid wash stem cell
cells, indeed.
debacle. I think that's just been, I've read on Nature that's just been retracted, which is...
That was PubPeer. So that was a site, this post-publication peer review site, where the papers went up, they got through peer review, standard, blind peer review, anonymous peer review, and got through that. Within, I think, days, people were commenting on PubPeer saying there's something very fishy about this data. That led to a group, I can't remember, somewhere in the US. Sorry, it's too late. I can't remember the specific group. But what he tried to do was to ask other groups around didn't try to do. He asked other groups around the world to see if they could reproduce this, and you had these various groups posting there, 8 or 9 groups saying no, we can't do this, and that led to everything unraveling. It turns out that the data were fabricated. So it's it's interesting. The whole sort of process of peer review is in a real state of flux now, and I think it's moving to something where the old guard, I think, and the traditional journal editors are very worried about it. But I think for you lot, going into a career in science, this will be de rigueur for you. You will, I think, 10 years, 20 years down the line, certainly, it will be the case where a paper goes out and, it will be commented on online, and that will be the real sort of acid test for peer review.
Maybe just on one last topic, I think we have 6 minutes left. The use, based on just what we just said, the use of peer review in application writing, applying for grants, is that going to move, do you think, from maybe not based on how many peer-reviewed journals a applicant has got, but rather based on more of their idea? I think this is one of the ideas raised at ESOF. You know what, I'd really like to think that were the case, Michael, but I just have no confidence in it. It's that will happen. It's depressing. I've sat on fellowship panels, I've sat on interview panels and selection panels for jobs, and there is still a hardcore of academics who will take somebody's CV, ignore practically all of it apart from the publications list, go down that publications list and count up the number of Nature papers, the number of science papers, the number of JACS papers, whatever, and that and only that is what they'll base their decision on. Getting beyond that is going to take a long time. I think we are incrementally chipping away at that, but that sounds very much holier than thou of me. But the worrisome thing is Deepak Chopra's name has just appeared. So the worrisome thing is that if I were to say, right, I'm going to, for example, boycott those top tier journals, as some have suggested, including a recent Nobel laureate, then I may as well, just say to the postdocs in the group, I've shot you in the foot. You're not going to get you're not going to get a job. We have to keep aiming at those journals because I know just how the process works. So the problem is you're locked into this vicious cycle, and it's deeply bloody frustrating. But ideally, what you suggest, Michael, is what should happen. In practice, that's definitely not what happens.
Well, what do you think about the potential now for crowdsourced science? Because one of the worries I see in that is that you're going to end up with a lot of very well funded but completely useless free energy machines on the internet.
There is that. It's interesting. I've explored crowdfunding with some people in the past, and it's interesting when we thought about it from the context of research initially, and ended up with exactly the same worries as you said. Is you've got to introduce some aspect of peer review, and how then do you actually do that, and still sort of connect with the people who want to get a particular project funded? Where I think crowdfunding could be really good is in terms of public engagement projects and outreach and those type of things, where you're talking about communicating the science rather than doing new science. But even if the stuff that isn't, how can I put it? Even if the stuff is entirely sound, you know, you've got a much more difficult sell on something which is fundamental science and isn't going to lead to a widget, a tangible widget, as compared to something which is, you know, give us your money and we will generate this, I don't know, wonderful new high density iPod or whatever for you. It's there's, you know, you could very easily see how fundamental science could get disadvantaged in a system like that.
Yeah, and even still, there'd be all you really have to do is mention something like cancer or something like that, and it could be completely repetitious work and something that may not generate any results or anything good. But if something that's less, maybe not a hot topic, but still could do a lot of good, that will get less funding. It's not really, what I'm trying to say is that the public really wouldn't be the best people to understand or decide where the money should go or where funding should go to fund projects.
Yeah, it's a tricky one. Obviously, we're publicly funded, so we have an obligation to be answerable to the public. The difficult, and so we have to be as open and honest. But the problem is there's something called upstream engagement, where there's quite, you know, well, I wouldn't say quite a large number, but there's certainly a number of sociologists and those in terms of public engagement with science who feel that not only should scientists be communicating to the public should be feeding in and directing how science develops. And that's really, for many issues, and that's quite troublesome. And that's, when you say it like that, it sounds very elitist, but you know, as you say, it's like the crowdfunding thing. If we direct resources in terms of the fads of the day and what's assumed to be maximal societal benefit at a particular point in time, we could be locking, or we would be locking out some very important science.
Okay, well, I think at that we'll just have to call it an hour. I just want to thank my guests, Professor Moriarty, Science of Sarcasm, and Sarah for this very interesting hour. And also just want to ask for you guys, who do you want to vote for in this year's Idiot of the Year Award, the prize for kind of a tongue-in-cheek prize for monumental idiocy. We have Deepak Chopra, Mike Adams, Ken Ham, or for some reason we have the Pope here.
For me, it's got to be Deepak Chopra, though. You've set up a fairly difficult choice there, but Deepak Chopra came out with there was that recent video.
I'm probably gonna go with Mike Adams simply because he's actually giving really bad health advice and turning people away from decent health advice, and is probably actively injuring people.
Fair point. Yeah.
Okay. Well, thanks for coming on, and it's been a great hour.
Thank you, Michael.
Thanks for having me.
What's the target? What's the total